Hello and welcome to the Hour of Code. For those of you I haven't had the pleasure of meeting or teaching yet, my name is Mr. Baumgarten and I'll be your guide through this next hour or so of exploring coding. First of all, is this session for you, or should you be using the existing tutorials on websites such as code.org? The quick and simple answer to that is, if this kind of puzzle you have done multiple times before and does it not strike you as something that would be at all a challenge, then this tutorial is probably for you. Okay, if you're familiar with the idea of using these repeat until loops and these if loops, so if we were to look at this problem, we would want to move forward in a repeat loop through all these blocks, right, such as like that, and if the path turns to the right, then we are going to want to turn right, and that will allow us to move forward. Whoops, path goes to the right, so we turn right, keep going, moving forward, path goes to the right, so we turn right, and we hit the sunflower, which is where we would stop. So now if I hit run, this will solve the problem. Okay, and there are many different variations upon this theme on the code.org website, but if this strikes you as something you have done multiple times before, then this tutorial is probably for you. If that strikes you as something that is you haven't seen before, you haven't done much of these before, then maybe you should be using a code.org tutorial. And so just speak to your teacher about that. So by the end of this hour of code session, the objective is that you will have produced a simple breakout game, something akin to what you can see here on the screen, where the ball is bouncing off the paddle and knocking out various bricks, and we keep score based upon how many bricks you knock out. That's a simple breakout game. So you probably won't finish the breakout game in the time allotted, but all the videos will be there available for you to complete it if you wish. We are also organising a competition for those students who complete these tutorials and wish to have a go at creating something of their own. So ask your teacher about that at the end of the session. Also, since this is taking a video form, please remember to make use of that fact by pausing and rewinding as necessary, so that you can follow along with what's going on. Because I will preempt right at the start that because time is so limited, I will have to race over some of the theory quite fast. But if you do follow along the instructions, you should still definitely have a working game at the end of the sessions. I have got video lessons that I've created for my ASA, which are slower and more explained. If programming is something that you are interested in learning more about, then please feel free to make use of those videos. Right, with that said, let's get started. Okay, so the first thing you are going to need is to install a Chrome app called Coding with Chrome. So if you click on your Chrome apps icon, this is what we're looking to install. So if I just flip back to Chrome, if you go to your Chrome app web store, simply type in Coding with Chrome into the search box, and it is an app. And I'm going to type that again. Hit enter. And it's still scroll down to apps, Coding with Chrome. Okay, install that, add that to your Chrome browser. Once you've got that loaded, this is the welcome screen that you'll see for Coding with Chrome. Okay, welcome to Coding with Chrome. We're going to go straight into the advanced area, so use advanced mode, then into programming, and then into JavaScript. And finally, we will click on a new empty project. And this is the screen that you will see and that we will be working in for the next little while. So how do we use Coding with Chrome? Okay, so it is using the JavaScript programming language. And there are a few other little niceties that have been added to it with to make things a little easier for beginners in Coding with Chrome. So we'll be making use of those as well. So for example, if I want to draw a little circle, I'll just simply click here in my text coding area, and I would use the command draw.circle, open some brackets, and inside the brackets I will provide parameters or the extra information that this draw.circle command needs to know in order to be able to draw me a circle. So if I put in the numbers 150, 150, 100, for instance, okay, and I close my bracket, and I click over here, this is my the screen or the stage where I will see what I've produced. I hit my play button, and I will get a big circle drawn. Okay, so what's going on here? Just a quick introduction. This is the X value for the center point of my circle. This is the Y value for the center point of my circle, and this is my radius value for my circle. So we can think of this stage here as an X and Y coordinate plane, just like you're used to with maths, with X going across horizontally and Y going vertically. So the top left corner is 0, 0. All right, so X is 0 here, and it increases along here to, on my screen is about 500, 600 across at the outer edge. Okay, and it's opposite to the Cartesian plane for your y-axis. So y is 0 at the top and increases as we go down. So this is y 150 here, and we keep going down to y about 300, 400, 500, 600 as we go down. Okay, and it will be similar on your computers as well. We have other shapes that we can draw and we'll be using, such as draw.rectangle. Now, on the circle, the X and Y value we gave was for the center point of the circle, and then we provided a size for the radius. On the rectangle, the X and Y values that we provide are for the top left corner. So, for instance, if I put 150, 150 again in here, the rectangle that we will end up with should start at the center point of the circle. Now, for a rectangle, we need more than just the top left corner. We also need to know the width and the height. So if I give this a width of, say, 300 and a height of 200, okay, and then we end all of our commands with semicolons. Okay, you can see now that I've got a rectangle that's emanating from the center point of the circle. Now, both of these commands also have an optional additional commands we can provide, such as on the circle here. If I inside quotes, if I put the color or the word blue, my circle will now be blue, and on the rectangle, let's put pink. Okay, so the quotes are for any time I'm wanting to use a value that is of text, which in programming parlance is known as a string. They start and end with a quote so that we know where the text begins and ends. As opposed to numbers, we don't need that, because as soon as the computer encounters something that's not a number, it knows that the number has ended. Alrighty, so we've drawn a couple of basic shapes. That's all very well and good. Let's start building our breakout game. Okay, so let's start thinking about the components of our breakout game. We need to have a little ball that is bouncing off of walls and paddles and bricks and things like that. We need to have our paddle down below, which we're going to control with our mouse. And then we need to have all of our bricks that are going to be drawn for the ball to hit. So let's modify what we've got here. If we're going to have a ball that's bouncing around, it needs to change its position. Okay, and we know that a circle, which is what we're going to use for our ball, right, the first two numbers are the X and the Y value that represent its position. So how can we change these in our program? Let's get rid of this rectangle. And the trick to doing this is by using what's known as variables, and these are simply memory locations that can store some information that we can then read and access, and we can also control, manipulate, and change. So for instance, if I would put in the keyword var, is short for variable, so I'm creating a variable and I'm going to call it X, and I'm going to give it the number 150. I'm going to create another variable, call it Y, and give that 150. So in my circle here, instead of just typing in, I want this circle to be at 150, I'll replace the first 150 with the X, and I'll replace the second one with the Y. Now this is still going to draw a circle in exactly the same spot, but this time we're taking the number 150, we're storing it into X, and then here in our draw circle command, we're seeing what is the value stored inside X, and we're using that. And the same with Y. We put the number 150, store it into this thing called the letter Y, and then here we're asking, well, what's stored inside Y? It's the number 150, and so we get the circle drawn. But it does mean now I can start changing these numbers if I want. Okay, and my circle moves along. Probably not so noticeable with that small change. Let's make a big change, and you can see, okay, my circle has definitely moved. And I can also perform additional calculations with these numbers along the way. So for instance, if I put in the command y equals y plus 300 and refresh that, my circle is now down at the bottom corner of my screen. So let's just take a quick moment to look at what's going on here, because mathematically this does not make sense as an equation in the form that you're used to. Okay, but this is the way that programming languages perform their calculations. The general principle to think of it is that it is performing a calculation with whatever is on the right-hand side of the equal sign, and it stores the answer in whatever is on the left. So in this case, y plus 300. Well, so what is currently inside y? So before we have done anything with this command, the letter y has the value 150. So this is saying, look up the value that's in y, 150, add 300 to it, which would be 450, and then store the answer into y. So that by the time draw circle is looking at y, it has the number 450 inside it. Okay, so just take a moment to get your head around that, because that is a key concept for what's going on. It'll perform the calculation that's on the right and store the answer in whatever we put here on the left. So we didn't actually have to make it y equals y. We could be, for instance, updating the value that's inside x, and that would be perfectly valid. We'd be saying take 150, add 300 to it, and store that value in x. And so this circle is now got an x value in the center of 450. Now we can take this concept and simply build on it to make a ball that is moving across the screen. Every fraction of a second we can perform calculations to adjust values that are inside x and y and make it look like a ball is moving. So how can we do that? If we want something to happen every fraction of a second, JavaScript has a handy little feature within it. So I'm just going to come up here to the top, and I'm going to type in the command set interval. And let's call this loop, and I'm going to put the number 40. Okay, so now you'll get an error message here. Loop is not defined. That's fine because we haven't defined it yet. I'm just going to quickly explain what's going on. All right, set interval is basically the command that initializes the timer function within JavaScript. The 40 represents how many milliseconds between on the clock between executing these commands do I want JavaScript to be waiting. Okay, so every 40 milliseconds we're telling JavaScript to look for and run a command called loop. Now we don't have anything here called loop at the moment, so we're going to create that in a second. So for every 40 milliseconds, there's 1,000 milliseconds in 1 second. So by putting the number 40 here, this is going to execute 25 times per second. So let's make this thing called loop. Okay, and the way we do this is we write the keyword function, right, and then the word loop. I'm going to open and close a set of round brackets, and then open and close a set of curly braces. Right, this is now my loop function. Okay, and what a function is essentially we're going to be pretty well using it as a way of grouping different statements or commands together, such as these, okay, and grouping them all together so that it can be accessed through this one reference name, in this case called loop. And we put those commands inside the curly braces. So if I move my cursor to be in between them and enter, whatever is between the open and the closed curly brace will get executed every time this function called loop is run. So if, for instance, if I take my draw circle and I cut and paste that into my loop function, right, this is now drawing a circle and redrawing a circle 25 times a second, or every 40 milliseconds. And how can I prove that this is constantly redrawing? Well, let's ask JavaScript to make changes to these x and y values. So instead of having this command here, all right, how about I put in here y is equal to y plus 1. And you'll see now that I have this big, long, growing shape, which is gradually moving down. So what's happening is we started with one circle, and then we moved down 1 pixel, drew a new circle, moved down 1 pixel, drew a new circle, moved down 1 pixel, drew a new circle. Okay, and so we're getting lots of circles being drawn over the top of each other. Now this is all well and good, but in our program, we're going to want just the appearance of one circle that's moving rather than one circle continually being drawn over on top of all the other circles. So how can we do that? Well, we actually kind of cheat a little bit, and we just draw a big white rectangle over our whole screen to clear it, or give the effect of clearing it every time that we run our loop. So I'm going to insert a new statement here for draw rectangle. And if I want it to clear the whole screen, then it's going to have to start at the top here, 0, 0. So 0, 0. And I want it to be as wide as the screen is and as high as the screen is. Well, how do I know how high and wide my screen is? It changes depending upon the computer that I'm using. Thankfully, JavaScript has a couple of little tricks up its sleeve that allows us to automatically find out. To know how wide our screen is, we use so that's basically an automatic variable. Right? So we created these variables, x and y, and there are some that always automatically exist within JavaScript that will tell us the size of our screen. You just need to know what they're called. So in this case, we're going to use window.innerWidth, right, for the width of our screen, and window.innerHeight. Right, these are case sensitive, so uppercase W, uppercase H. All right, and you can see now we've got our circle that is moving. Now I want to make it white, so I'm going to put in my color command. And now it looks like I've got my circle that's simply moving. And I can change my x value as well if I want. Let's make x move to the left by putting in a subtraction. And you can see that my circle is slowly moving down and to the left. All right, and so we're going to just modify this slightly, and this creates our ball that's moving around the screen. So let's make it a little bit smaller. 5. Okay, that's about the right size that I want for my Pong game. Right, a little ball that's moving along, and I need it moving a little bit faster, so let's try adding and subtracting 5 from it each time. All right, and that's moving at a decent speed to get started with my game. Now the next thing I'm going to want to do is to make my ball be bouncing off the edges so that it stays on the screen. So how can I do this? I can use what's known as an if command, an if statement. So I'm going to insert another blank line, and basically what's happening is my x is getting smaller and smaller, approaching 0, and then it's actually still getting drawn here, right? And we're just continually taking 5 off of it, so x will become -5, -10, -20, okay, and it's just appearing off of my stage. So I can check to see if x has become negative, then I don't want it to become negative anymore. All right, so if x has become less than 0, right, and so you can see this kind of works the same as our function. I've got a keyword, I've got something inside round brackets, and then I've got a set of curly braces. So basically what will happen is, if whatever question I put here in my round brackets is true, then it will execute the code that is in my curly braces. Okay, so what can I put in here that will take care of this situation of where x becomes less than 0? All right, and this is where I'm going to create another couple of variables. up the top here, my X direction, right, is -5. And so now, down here, instead of having -5, I'm going to replace this with adding my X direction. And we'll see the circle still works exactly the same. In this calculation, right, we're taking whatever the value was in X and we're adding whatever is in this X direction value, okay, which happens to be -5. So we're still subtracting 5 off of it each time. But what I'm going to do now is with this if statement, if we've become less than 0, right, to give the effect of bouncing off this wall, instead of subtracting 5 each time, I want to start adding 5 and it will start moving back the other way. So all I need to do then is if X has become smaller than 0, I'm going to say X direction is going to become +5. And now, as we run our code, we'll see that the ball should bounce off. All right, it's got the appearance of bouncing off this this left edge. And I can do the same for my other edges, and all of a sudden we'll have a ball that's bouncing. So if, all right, so the other place that it gets stuck is down here, Y. If Y becomes larger than, what's the bottom down here? Okay, that's the total height of my screen, which we already know how to access. We've got this thing up here. So if Y becomes larger than my window dot inner height, all right, then I want a Y direction. So I need to create a Y direction variable. All right. And so here, let's change this to Y direction. All right, so if Y becomes bigger than the inner height, then my Y direction is going to have to become minus because I want it to start heading back up. And now if we watch our ball, bounce and bounce. Excellent. So this is working so far. Now I just need to do the same for these other two walls. All right, if X is bigger than window dot inner width, then what do I want to change this time? If I'm bouncing off this wall, I've been adding to my Y value, so I now need to start decreasing it. So X direction becomes -5. And now for the top wall, if Y is less than 0, my Y value has been getting smaller and smaller until it becomes negative, so I need to start adding to my Y value. So Y direction. All right, and so as you can see, we have a ball that's bouncing back and forth between these X and Y coordinates and bouncing off all four sides. Fantastic. So we have the first part of our game happening. We've got a ball moving around. Let's try adding the second part now. Let's get a paddle here that we can use for the ball to bounce off of. Right, so we'll actually later on have to remove the bounce off the bottom basement, if you like, of the game, because the idea is that we use the paddle to keep the ball in, and if the paddle doesn't catch it, the ball just falls through and the game ends. Alright, so let's create a paddle. Right, so a paddle is just, we're just going to use a rectangle. Right, draw dot rectangle. We're going to need an X and Y position for this. So let's just use 200 for now. Paddle probably use a width of about 50 and a height of about 20. And I'm just going to make my paddle black for now. You can make yours whatever color you want. Right, you can see here, if your eyes are really good, you catch that the paddle just suddenly appears and then disappears. Right, that's because we've got it down here. So it happens once when I restart my program, but then it's getting quickly erased by this, because we're drawing this rectangle over the whole thing 25 times a second. So I need my draw rectangle to actually be inside my loop if I want it to stay on screen. So that's fine. I'll cut and paste it into here. And there's my rectangle. Let's get rid of this big red screen. All right, now that's not where I want the paddle for my game. I want it kind of just a little bit off the bottom. So instead of Y being 200, I'm going to say, let's take whatever I know that the bottom of my screen is this window.innerHeight. So if I copy that and paste it in here, right, now we can't see it because this X and Y value is the top left corner of the rectangle. So it's actually hanging just off the bottom here. So I'm going to then take my window.innerHeight and let's subtract 50 from it, for instance. And all of a sudden now we've got a rectangle that we can see. Because it's 50 up from the bottom corner there. Now I want the X position of my rectangle to change according to where my mouse is. I'm going to use my mouse to move my paddle around the screen to catch the ball. So how do I know where the mouse is? To find out where our mouse is, we're going to create another function, which we will get JavaScript to automatically execute whenever the mouse moves. So let's just call it mouse move. And this time, inside the round brackets, I'm going to just put the word event. And then we'll have our curly braces there. So how do I get JavaScript to run this function whenever the mouse moves? Well, I'm going to come up here where I've got my set interval. And this one is a little longer. It's document.add event listener with a capital E and a capital L. And this time, inside quotes, I'm going to use the magic command for mouse move. And then I'm going to have mouse move again. And call. Right, so what's happening here? I'm telling the document, which is the fancy name for our screen happening here on the right, to listen for an event. What is the event I want it to listen to? I want it to listen to the event known as mouse move. So this is just an arbitrary name that JavaScript gave this command. Whenever mouse move happens, I want it to execute this function. Right, so it's only coincidence that these two words are the same. Right, they could be anything, but in this case, it makes sense to use the same name. So execute this function. So it's going to look for and find, oh, here's a function called mouse move. I'm going to execute that. Okay, so what do we want our mouse move function to do? Well, really all I need is the X coordinate of where my mouse is. And then I want to somehow put it in here where my rectangle is being drawn so that my rectangle gets drawn at that same spot. How can I do that? Well, I can just create another variable to keep track of this so that one function can change it and then another function can listen to it. So let's just say, call this the X for my paddle. All right, and it can start at 50 or whatever. But down here in mouse move, so every time the mouse moves, let's listen for and find out what the X. So every time the mouse moves, we want to find out where the mouse has moved to. And we do so by looking at this event thing. Basically, this is information that JavaScript gives us regarding the event that we are listening for, which in this case was when the mouse moves. And so inside this event, this variable is a value called offset x. And that basically tells us the x value of the mouse within our canvas or our stage that we have here. So whatever value is in this thing, I want to store it in this x paddle. So x paddle is equal to the mouse coordinate that I moved to. And then when we draw our rectangle, we simply want to use the x paddle. Okay, so now if I look inside here, I now move my mouse and my paddle moves with me. Fantastic. Now there is one slight little change we're going to make to this. You notice that the mouse moves, right? And as the mouse moves, it's the top left corner of the rectangle that is in line with the mouse, right? Because that's what this x value is. Now, it will be easier to play the game if the paddle is kind of centered upon where my mouse is, rather than just the top corner of the paddle. So inside here, whatever this x paddle is, how about we know here that the width is 50, so let's take half of that off of it, 25, and now you'll see that my paddle is centered upon where my mouse pointer is. All right. So far we've got a ball bouncing off the walls, and we have a paddle that's moving. The next objective is to make the ball bounce off the paddle. If the ball hits the paddle, then we just want to change our Y direction. So have it, instead of Y increasing, we want it to start becoming negative because it's bounced off the paddle. Okay, so that's what we need to do to change the ball. How can we detect if we hit the paddle? Well, basically we just need to know if the ball is somewhere inside the X and Y values taken up by the paddle, right, which is from the top left corner through to the bottom right corner of that paddle. So we're basically going to use a bunch of if statements to do this. And we'll do it inside our loop so that every time we're redrawing and recalculating our ball position, we check to see if we bounced off the paddle. And I'm basically going to ask the questions. If the Y, all right, so let's start with X value. If the X value of the ball between the left edge and the right edge of the paddle. So X is the X coordinate of the ball. And if that is larger than or equal to, what's the left edge of my paddle? Well, I actually already know that. That's here. That's paddle minus 25 because that's the top left corner is that and that. So if X is greater than or equal to X paddle minus 25, what do I put in the curly braces? Well, I also need to check to see if it's within the right-hand edge of the paddle. If X is less than or equal to, what's the right-hand edge of my paddle? Well, I know that my paddle goes for 50 pixels. If minus 25 is the left edge, then X paddle plus 25 will be my right edge. Okay, now I need to check my Y values. What's the top of my paddle? Again, I already know that. That's right here. So if the Y value for the ball is greater than or equal to window dot inner height minus 50, and finally, what is the bottom edge of my paddle? Again, I know, okay, so if this is the top edge, and then this is the height that I'm drawing it, alright, so it'll be that plus that, which basically works out to be window inner height minus 30. So if Y value for the ball is less than or equal to window dot inner height minus 30. If we're within the left edge and the right edge and the top edge and the bottom edge, then what do we want to do? We want to change our Y direction so that it starts heading up. We want our Y direction to get smaller, so we want to be subtracting 5 off of it after the bounce. So we want this. So Y direction becomes minus 5. And now, hopefully, if I move my paddle there, the ball will bounce off my paddle. Let's get it back down here again. Yes, there we go. The ball is bouncing off my paddle. Fantastic. One more time. There we go. Okay, so the ball is bouncing off my paddle. One more thing done. Now we can change this. While we're at it, let's change so that the ball no longer bounces off the bottom of my game. So here, if the ball has fallen through the bottom of the game, what do I actually want it to do? I actually want the game to be over at this point. So we can draw, instead of bouncing, we'll get rid of that. And we can draw a message on the screen using draw.text. And then we can say game over in 250, say 300. And we'll make this red letters because it's big important news, the game is over. There's only one slight problem with this at the moment. is that the ball is actually still moving. It's just moving off screen. So we'll also stop the timer so that our program basically ends. And so to do that is I will just type in the command clear interval, and we want to clear the first interval that we created. So here we created an interval, we set it, and then here when the game is over, we'll just clear it so that the game stops. And that will stop that loop code from running, which you will see now as I move my mouse, the paddle stops. The paddle is not doing anything. When I didn't have that, if I just put a slash slash, double slash turns code into a comment, so it gets ignored by JavaScript. Okay, so it doesn't have an effect. So if I move my mouse out of the way, let the ball fall through the bottom, we'll see the mouse is still moving because this loop is still running, and so it keeps drawing the rectangle and recalculating its new position. Whereas if I let that code take effect, the mouse will stop moving. Fantastic. Okay, so just while we're talking about the idea of comments, it is actually really good programming practice to get used to the idea of putting in comments so that if another programmer is looking at your code, they can understand what's going on. So I'm actually just going to quickly insert a few comments here. So it's 2 slashes, creates a new comment. So draw a rectangle to clear the screen. So just so that when we come back to this later on, we understand what is going on. Here, we're going to move the ball. And then here we check if the ball bounces off the left edge. Check if the ball falls through the bottom of the screen. Check if the ball bounces off the right edge. Check if the ball bounces off the top edge. And then here, check if the ball bounces off the paddle. What else do I have going on in my loop? All right, draw the ball, draw the paddle. Now the code's a lot easier for someone else to understand if they happen to look at it. Let's move on to drawing our bricks. So we need a whole stack of bricks across the top here for the ball to be bouncing through. So let's start drawing some bricks, shall we? Okay, so I'm going to use the same size and shape as my paddle for my bricks. I'm just going to put 50 wide, 20 high, a whole series of rectangles across the top. So let's put these in. Let's insert new lines up here. Draw the bricks. I'll just stick with putting in some comments. Okay, so I'm going to draw a rectangle, and like I said, so we'll just start with 0, 0 for now. That's going to change. And bricks will be 50 wide, 20 high, and let's make it a black brick for now. Okay, so I've got a black brick up the top corner. Now, I'm going to want about 50 or so bricks in my game. How can I do this? I could copy and paste this line 50 times and keep changing these X and Y values. Alright, so let's have a bit of a gap on the first one. So 20 in from the side. If it's 50 wide and I want a gap of about 20, so if the previous one was 20, then the next one would have to be about 90. Okay, and then add another 70 to that would make the next one 160, and so on. You can see how I move my bricks across, and I don't really want them on the top edge. Let's bring them down by 20 as well. Alright, so if I keep adding 70 each time, this will give me 230, 300, 370, 430. Right, so we can see, that one's not right, what did I do there? 440. Alright, so we can see I could keep doing that and adjust these X and Y values each time, but that gets quite monotonous. And I can let JavaScript work it all out for me. All right, which, similar to our functions in our if statements, right? We've got the one key word, we've got some round brackets, and we've got some curly braces. Okay, and whatever goes inside the curly braces is what will happen when the while loop is true. Okay, and like the if statement, basically whatever question or condition I express inside the round brackets, while that is true, and this loop will keep executing. It'll run over and over and over and over whatever's inside here. So I can simply put in here one draw rectangle command. Okay, and if I've got a variable for the x value for my brick, and I wanted to start my first rectangle with an x value of 20, okay, I can draw the rectangle at that x value, keep everything else the same. All right, and I wanted to increase by 70 each time. So x brick is equal to x brick plus 70. And all right, let's use this 440. Okay, while x brick is less than or equal to 440. And now I can get rid of all this, and this draws all my bricks for me. Okay, because it's simply increasing this x value by 70 each time and drawing in a new one. So I can change this 440. Let's add another 70 to that, 510. And now all of a sudden I've got an extra one. I've got 1, 2, 3, 4, 5, 6, 7, 8. Let's add another 70 to that, make it 580. And I'll get 9 bricks. Now I want rows of this. Okay, so I could, if I wanted to, put in another row here by simply changing the y value, and then put in another one. But again, we're falling into the same trap. We're doing something fairly repetitious, and manually updating the values each time. But when it comes to repetition, that's something that programs do very well. So let's get rid of those and let our program do it for us by creating a y brick value. Right, and we're going to start off with 20. So we'll draw these bricks there. Right, and we can just put a while loop inside another one. So while the y brick value is less than, let's say 100, okay? I'm going to cut this line and paste it in here. Right, and at the end of each rectangle, let's increase our y brick. My lines all lined up. And we'll add, what is it? So if it's got a height of 20 and a gap of 20, so we'll add 40 to it each time. Okay, and we're getting an error here. Brick is not defined, and that's because here I put the word brick, which is not a variable that I've created. I created y brick. Just also, while we're on this little guy up the top here, right, is a little debugger that should help also spot some errors for you as you go, although it's not actually helping with this particular error. But if I fix up my variable here and put y in, right, I now have these 3 going down. All right, now the problem I've got to have here is this statement actually belongs in here, because I need to reset my y back to 20 each time. Right? Otherwise, it'll just skip over all that because y is already bigger than 100, and so nothing was getting drawn past the first row, as you saw just then. So if I want even more y bricks, I just change this y, and all of a sudden I've got another row. Right, so if I went all the way to 400, for instance, I'd get a crazy amount of rows. So you can adjust these numbers as you want, depending upon how many bricks you want, and JavaScript will automatically work it all out for you. Okay, so I'm going to keep mine like that. Okay, 9 bricks across, 5 bricks down. Sounds like a good number. Okay, so there is my bricks drawn. Fantastic. Okay, so as far as the game is concerned, really the next thing we just need to worry about is the ball hitting a brick, and if so, then the brick gets killed and is cleared. And if not, then it keeps, if the brick isn't there, then it keeps moving on through. And then if it is, it kills the brick and bounces. Okay, so how can we do that? Well, we're going to kill two birds with one stone doing this. And we're going to use what's known as an array. So back up the top here, I'm going to create an array. I'm going to call this bricks equals, and this time I'm going to use square brackets. And inside here, I'm going to put the colours that I want my bricks to be, okay? Because it's it's a bit boring them all being black bricks. So let's put in some different colours in here. So we'll put in blue. Let's put in some green bricks, some yellow, magenta. What else have we got? We can use cyan. You get the idea. Orange. So basically, an array is a variable, okay? But instead of it just being a variable with one value, it has multiple different values, and we use an index number to indicate which value we want. So there's 6 different values here. All right, let's create a new variable for this. We'll call it this bricks color. All right, and we'll start with the value of 0. So to access the individual elements for here, all right, I use this variable. So instead of the word black, I can use bricks. And if I put a 0 in here, it'll make them all blue, all right? Because I'm saying, give me the first item, which is blue. If I change it to a 1, they'll all go green. If I change it to a 2, they'll all go yellow, and so on. Which brings me to one important point. Whenever computers count, they always count starting from 0, not 1. So that's why saying bricks 0 is going to be the first item, which is blue. Okay, now rather than just putting in 0, 1, or 2, I can also use a variable in this place. So we'll use this variable that I just created, this bricks color. Right, and that will make it all blue because this brick's color is currently set to 0. So after I've drawn a brick, right, this brick's color is equal to this brick's color plus 1. Right, so we will iterate through and we'll get some different colors showing through. So every time we draw a brick, we'll increase our color value so that the next brick gets drawn of the next color. Now the problem is we only have 6 colors here, okay, but we've got more than 6 bricks. We'll just say if this brick's color is greater than however many colors we have here, okay, and there is a handy little thing with arrays that tells us how many items are in it, right, and that is through using dot length. In other words, bricks dot length, right, this currently has the number 6 in it. Right. If we're bigger than the length, we'll just say this bricks color is back 0. And so we'll iterate through all the different colors. We'll get these grey ones appearing because, remember, like I said, computers start counting at 0. So 0, 1, 2, 3, 4, 5. So we actually want to know if this value is bigger than bricks length minus. As well, there's 6 items. The last one is accessed through the number 5. And now you see we got rid of the greys, and we just have our blue, green, yellow, magenta, cyan, and orange being rotated through. We're going to use a similar approach to tell if our brick is dead. Bricks alive. To do this, all right, this is where we need to know how many bricks we're going to draw. So we've got 1, 2, 3, 4, 5. All right. Vertically by 1, 2, 3, 4, 5, 6, 7, 8, 9 horizontally, so there are 45 bricks. So if a brick is alive, we'll call it 0, shall we? So 0, 0, 0, 0, 0. Okay, this is the one bit of repetition we're going to have to do. We need 45 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 1, 22, 23, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45. Okay, so if you drew yours with a different number of bricks, you need to make sure you've got the right number of zeros in there to match your program. Okay, and so what we will do is whenever the brick is dead, we'll work out which brick it is, and we will set it to something other than 0. Only if it's set to 0 that we will draw the brick. To do that, let's also just come in here. All right, if bricks alive, whatever this brick number is, which is something we're going to have to create, we will then, that is when we will draw the rectangle. Okay, so we need to create this bricks number thing. All right, go here, brick number, start with 0. And every time we are having drawn or processed an individual brick, we will increase it by 1. Sorry, so if bricks alive, right, bricks number equals 0. Okay, we'll make this. So what we've just done here is we're asking this question. Does, all right, for brick number 0 through to 45, all right, look inside the array, get that record, so the first brick, the second brick, the third brick, if it is equal to 0, which is what triple equals is asking. Okay, is this thing equal to 0? Previously we used less than or equal to signs. Okay, and the same with our if statements down here. Ask if it equals 0, or if one number equals a number, we use the triple equals. We used single equals when we are making a change to a value. We use triple equals when we're doing a comparison between two values. Right, so the next thing we need to do is to be able to set a brick to no longer being alive. Change it to something other than a 1. So at the moment, other than a 0. If I put 1s in here, you'll notice that bricks will start disappearing. So this is what we need the program to be able to do. We need to change these from 0s as the ball moves through and bounces off the brick. So let's do that as we move through here. We've moved the ball, we've checked we bounced off the edges. So let's put in here, check if the ball bounces off a brick. It's going to look very similar to what we just did for bouncing off the paddle. We need to check to see if the ball has moved into the space between the left edge, the right edge of a brick, and the top edge and the bottom edge of that brick. And if it has, then we will kill the brick. But we need to do it for all 45 bricks. This is where we're going to get a little mathy, a little procedurally, okay, but the same essence is going to apply. We're going to be looping through all 45. But rather than worrying about these x and y coordinates here in quite the same way, we can do it a slightly different way. We know brick number, and while our brick number is less than 45, or the other way of doing it, we know that 45 is also bricks alive dot length, and so then that way we could change the length and it won't affect anything. Bricks alive dot length, and we will run this loop, increasing brick number each time. Okay, so we've got something going on, and while brick number is less than the length of the number of bricks we have, which is 45, we're going to keep going through. And so we want to check for each individual brick number, am I passing through that particular? Okay, so we're going to create an X brick and a Y brick similar to like we did here. All right, X brick starts at 20, and is what we were using up the top here, wasn't it? Yes, and the Y brick was also 20. So X brick is 20, y brick is 20. Here I've got these little exclamations. Right, x brick is already defined, y brick is already defined. That's because I created them up here. Right, so I don't actually need this word var anymore because it already exists. But all I need to do is set it to the position, to the value that I want. Yeah, okay. Let's fix this up as well. Create var y brick up the top here. And then here with each loop, we'll just get rid of the var. Okay, that'll fix up the error. Basically, the error was being caused because I had the word var in here. And so the variable technically only exists within these curly braces. Right, so I could then create another variable down here called ybrick, but the reason I was getting the error is the program was saying, look, ybrick doesn't really exist here, but I know you created something called ybrick later on, and if that's the one that you're intending to use, you can't, it doesn't really quite work. The program warning me that there is a potential problem. So by making those quick little changes I've just done, it's gotten rid of the error message. I'm letting the program know, yes, I'm aware that this ybrick exists elsewhere. Okay, now every time I am looping through this, actually I need these at the start of my loop, don't I? Right, so before I loop through my 45 bricks, let's reset. Okay, I'm looking at brick, X brick starting at 20 and Y brick starting at 20. As I loop through, the first thing I'm going to do is to move on to each relevant brick. All right, my Y bricks increased by 40, my X bricks increased by 70. All right, so Y brick is equal to Y brick plus 40. I made that same error as previous. Put in the Y. All right, and if Y brick is larger than, how many does this go for? This goes to 200. All right, so if Y brick is larger than 200, then I'm going to set Y brick back to 20 and move on to my X bricks. All right, so that moves between each brick that I'm looking at. Okay, so but that's after having a look at the individual brick, because these are the values that I need for my first brick. I need to check if if the ball is bouncing off this particular brick. All right, and then I'm adjusting the X brick and Y brick values for the next loop. How do I check if the ball is bouncing this particular brick? Very similar to what I've got going on here. If the X position is greater than or equal to X brick, all right, because that's the top, that's the left edge of the brick, so I don't need the minus 25 already. If the X position is less than or equal to X brick plus the 50, if the Y position of the ball is greater than or equal to Y brick, and if the Y position is less than or equal to Y brick plus 20, that means the ball is passing through this particular brick. Excellent. So what do I want to happen when the ball hits the brick? I want to kill that brick. Now I know that to do that, I use this bricks alive. So bricks alive, for which particular number inside bricks alive? Well, I've got my brick number here, and I just need to set it to something other than 0, so equals 1, and we'll see that as the ball moves through those bricks, they will disappear. All right, that's all very good, but really I need it to do more than that. I need the ball to bounce off of those bricks. All right, we're going to make the assumption, since the bricks are longer width-wise than they are height-wise, that we are bouncing off the vertical. All right, so we're going to change the y value of changing our y direction, okay, rather than worrying about, oh, should we be bouncing off the left or whatever. Okay, and so to do that, I need to change my y direction. Now, how do I know if I want to change my y direction to be positive 5 or minus y? I don't really need to know. I just need to know that I want the opposite of what it currently already is. If it's positive y, so that it's coming down, and it hits a brick, then it needs to become minus y to move up. Likewise, if it's minus y, the ball's moving up, then it hits a brick and it needs to be positive y to move down. So I just need to say y direction is equal to the inverse, the swap. We'll swap the sign of whatever y direction already was. So, because if it's positive 5, there's a glitch here that we'll fix up in a sec. All right, think about this. If y direction is positive 5, then the minus sign is going to turn it into minus 5. If it's minus 5, or y direction is minus 5 currently, then it becomes minus 5, which will turn it into positive 5. Okay, so what's the little glitch that's going on here? At the moment, we're bouncing off bricks that even if the bricks aren't appearing, okay, because we aren't actually checking here. Is the brick still alive before we decide we're going to bounce off of it? We'll insert one last if statement here. If bricks alive, brick number is equal to 0. All right, whoops. That is when we will do these. So I'll cut those, paste them into there, and now we won't be bouncing off bricks that no longer appear. That's flowing a lot better. Okay, so our game is almost complete. Probably just make the ball start a bit lower in the game so it's not going through and wiping out half the bricks before we even start. So where's the starting position for our game? Okay, y, so the x and y are for the ball. So let's make it start at 250 instead of 150. So it's a little lower in the screen. It has to bounce off the paddle before it starts taking out the first bricks. Well, that's starting to play a lot more how we would expect. The last thing we need to do is keep a score so we can see if we are beating our mates. All right, so we will simply do that by var score equals 0. This is the easy part. We gain a score every time we hit a brick. All right, and we know that we're hitting bricks here. All right, so score is equal to score plus 1. And then when the game finishes, let's print out a score. All right, so we'll come up here where we draw the game over. We'll draw .text score. All right, and we'll add our score number to that. We'll put it in roughly the same place, 200 and 330, make that red as well. All right, so now we will get a score when the game finishes. Okay, so now we get a score when our game finishes, and there you have it. We have a simple little breakout game. I hope you enjoyed making that. Gained an appreciation of what it's like to do some real coding instead of just playing with blocks all the time. If you are interested in more, like I said, there are videos that I have created for my after school activities club on an introduction to coding. Please feel free to look at those. You can access them through my website, paulbaumgarten.net. Then click on courses and then click on ASA, and you will find the video links in there. Don't forget the game programming challenge. Ask your teacher about that. And finally, I have a quick little survey I would appreciate if you could fill out for me, just indicating if you found this activity to be useful. If you are interested in anything more about programming, please feel free to come and find me and talk to me. I'm always happy to help students out who are interested in programming and get them up and running, because it's an incredibly valuable and fun skill to learn. And so I wish you all the best in that, and hope you continue to pursue it further. All right, this is Mr. Baumgarten signing off.